When installing a subpanel that receives power from an existing single-phase 240 volts panel, proper grounding is essential for safety. Here's how to correctly ground the subpanel. Firstly, you must establish panel grounding. Install a grounding electrode system, such as a ground rod or connection to a metallic cold water pipe, near the main panel. Connect this grounding electrode system to the main grounding bar within the main panel. Secondly, connect the main ground to the subpanel. Run a separate ground wire from the main grounding bar in the main panel to the ground bar in the subpanel. This wire should be the same size or larger than the neutral wire. Do not interrupt or separate the main ground wire. It should run continuously from the grounding electrode system to the subpanel. Thirdly, address the grounding within the subpanel itself. For equipment grounding, connect all equipment ground wires, which are typically green or bare, to the separate ground bar in the subpanel. It is crucial to keep these separate from the neutral connections in the subpanel. For neutral grounding, do not connect any neutral wires to the neutral equipment ground bar in the subpanel. Fourthly, ensure proper neutral bonding. The neutral bar in the subpanel should not be bonded to the panel enclosure. The neutral is already bonded to ground at the main panel, so bonding it again at the subpanel would create a ground loop, which is undesirable. Fifthly, connect neutrals correctly. Connect all neutral wires, typically white in color, to the neutral bar in the subpanel. It's vital that equipment grounding provides a path for fault currents to return to the main panel and the grounding electrode system. The separate ground wire from the main panel to the subpanel ensures a reliable ground connection for the subpanel, even if the neutral wire were to become disconnected. Now let's delve into some additional considerations for clarity. The grounding electrode system is what provides the primary reference to Earth, ensuring that in the event of a fault, current can safely flow back to the source and trip a breaker, preventing electrical shock hazards. The size of the grounding electrode conductor, the wire connecting the grounding electrode to the main panel's ground bar, is determined by the size of the service entrance conductors and is outlined in the National Electrical Code, or NEC, Table 250.66. The equipment grounding conductors, those green or bare wires connected to the subpanel's ground bar, are sized according to NEC Table 250.122. Based on the rating of the overcurrent protective device, such as a breaker or fuse protecting the circuit. When running the ground wire from the main panel to the subpanel, it's important to choose a conductor type that is approved for grounding purposes. Typically, copper or aluminum conductors are used. The size of this conductor is determined by NEC Table 250.122, as mentioned earlier. The purpose of the separate ground bar in the subpanel is to isolate the equipment grounding conductors from the neutral conductors. This separation is crucial for preventing neutral currents from flowing on the equipment grounding conductors, which can lead to nuisance tripping of ground fault circuit interrupters, or GFCIs, and can also create potentially hazardous touch voltages on equipment enclosures. The neutral bar in the subpanel is insulated from the panel enclosure to prevent any unintentional grounding of the neutral. This insulation is essential for maintaining the integrity of the grounded neutral system and preventing ground loops. When connecting the neutral wires to the neutral bar, ensure that each wire is securely terminated and that there are no loose connections. Loose connections can cause arcing, which can lead to overheating and potentially start a fire. Do not bond the neutral bar to the subpanel enclosure. This is because the neutral is already bonded to ground at the main panel, and bonding it again at the subpanel would create a parallel path for neutral current, which can lead to inaccurate readings on ground fault detection equipment and can also increase the risk of electrical shock. The equipment grounding conductors connected to the ground bar should be bonded to the metal enclosure of the subpanel. This bonding ensures that the entire enclosure is at the same potential as the equipment grounding conductors, which helps to minimize the risk of electrical shock. Ensure that all connections are tight and corrosion-free. Use appropriate connectors and terminals that are listed for the specific type and size of conductor being used. When installing the grounding electrode system, follow the requirements outlined in NEC section 250.50 through 250.70. These sections cover the types of grounding electrodes that are permitted, the methods for installing them, and the minimum requirements for their resistance to ground. Ensure that the grounding electrode system is properly maintained and inspected regularly to ensure that it is functioning correctly. If the resistance to ground of the grounding electrode system is too high, it may need to be supplemented with additional grounding electrodes or improved by other means. When working with electrical systems, always follow safe work practices and wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. To energize the circuit before working on it whenever possible, and use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electrical systems, consult a qualified electrician. They have the training, experience, and equipment necessary to perform the work safely and correctly. They can also ensure that the installation meets all applicable codes and regulations. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC is published by the National Fire Protection Association, or NFPA, and it is available for purchase online or from bookstores. Local jurisdictions may have additional requirements or amendments to the NEC. It is important to check with the local electrical inspector to determine the specific requirements in your area. A permit may be required for electrical work. Check with the local building department to determine whether a permit is required and to obtain the necessary forms. The electrical inspector will inspect the work to ensure that it meets all applicable codes and regulations. It is important to schedule an inspection before energizing the circuit. Proper grounding is essential for electrical safety. By following these guidelines, you can ensure that your subpanel is properly grounded and that your electrical system is safe. Always consult with a qualified electrician if you have any questions or concerns. When choosing the location for the subpanel, consider factors such as accessibility, clearance, and environmental conditions. The subpanel should be located in a dry, well-ventilated area that is easily accessible for maintenance and repairs. It should also be located away from sources of heat, moisture, and corrosive substances. The subpanel should be mounted securely to a wall or other suitable support structure. Use appropriate fasteners that are designed for the type of wall or support structure being used. Ensure that the subpanel is level and plumb. When wiring the subpanel, use appropriately sized conductors for the circuit amperage and voltage. Refer to the NEC for conductor ampacity ratings. Use only listed and labeled electrical components that are designed for the intended application. Follow the manufacturer's instructions for installation and use. When making connections, ensure that the conductors are properly stripped and terminated. Use appropriate connectors and terminals that are listed for the specific type and size of conductor being used. Tighten all connections securely, but do not over-tighten them. Over-tightening can damage the conductors or terminals. Label all circuits clearly and accurately. Use a permanent marker or label maker to create labels that are easy to read and understand. Keep the subpanel clean and free of debris. Dust, dirt, and other contaminants can accumulate and cause electrical problems. Inspect the subpanel regularly for signs of damage or wear. Replace any damaged or worn components promptly. If you are unsure about any aspect of the installation or maintenance of the subpanel, consult a qualified electrician. They can provide expert advice and assistance. Remember, electrical work can be dangerous. Always take precautions to protect yourself from electrical shock. By following these guidelines, you can ensure that your subpanel is properly installed and maintained and that your electrical system is safe and reliable. Remember to consider the specific requirements of your installation when selecting the size and type of conductors and overcurrent protection devices. Consult with a qualified electrician if you have any questions or concerns. Proper grounding is a critical safety measure that helps to protect people and equipment from electrical shock and fire hazards. By following these guidelines, you can ensure that your electrical system is properly grounded and that it meets all applicable codes and regulations. Be sure to consider local amendments and regulations. Also, the grounding electrode conductor must be continuous and spliced. Approved splicing methods exist for larger sizes. The size of the neutral conductor is determined by the calculated neutral load. It cannot be smaller than the equipment grounding conductors. Be sure to use appropriately rated tools for all electrical work. Double-check all connections to ensure tightness. A loose connection is a high-resistance connection. High-resistance connections create heat, which can cause fire. Ensure branch circuit wiring is neat and properly supported. Wires should not be pulled on or stretched tightly. Wires should have some slack. When working on electrical equipment, it is important to be aware of the potential hazards and to take steps to mitigate those hazards. Electrical shock can cause serious injury or death. Arc flash can cause severe burns and other injuries. Electrical fires can cause significant property damage. If you are not comfortable working with electrical equipment, it is best to consult with a qualified electrician. They have the training, experience, and equipment necessary to perform the work safely and correctly.